Assalamualaikum, hope you all are fine. In this video, we will learn about the Friedel-craft reactions. So firstly, we will discuss the Friedel-craft alkylation reaction. In this reaction, we will take an aromatic compound such as benzene and an alkyl halide such as methyl chloride, and in the presence of some catalyst that is Lewis acid aluminium trichloride, and we will get the final product or main product as toluene and a byproduct that is hydrochloric acid. So we will discuss its mechanism. uh, so firstly, in the first step, removal of chlorine from alkyl halide to form the electrophilic species, that is an electrophile that contains a positive charge on it. So the methyl group is an electrophile that acts as an electrophile. So the second step is this electrophile will attack on some whether it is pi bond, whether it is this pi bond or this pi bond. So it will break the pi bond and will convert into a carbocation form, and that in this step this benzene will lose its aromaticity because of the pi bonds and the alternative on the alternative position. This is known as the aromaticity, and when one pi bond will break, it will convert into a carbocation. So in the third step, loss of proton from the carbon that is attached to the methyl group, and in this step the loss of proton is the main process in which the this hydrogen will gives its electron to form the pi bond, and when this pi bond regain its original position, and it will convert into a final product that is methyl benzene or toluene, its common name. And when this proton will react in the fourth step, that is with the aluminium tetrachloride, and in this reaction aluminium trichloride is the stable form of aluminium, and from this the one chlorine will attack on the proton, and this will convert into a byproduct that is hydrochloric acid, and this is the catalyst that we regain from the as the reaction proceeds, we regain the catalyst. The next is Friedel-craft acylation, and in this reaction we take an aromatic compound that is benzene, and it will react with the acylating agent, and that is acetyl chloride. And acetyl chloride is known as acetyl because the carbon that is attached to the other carbon, and it will also attach with the oxygen with double bond and a halogen, so it will known as acetyl. This will known as acetyl, and this is chlorine. So acetyl chlorine or chloride, and in the presence of Lewis acid catalyst that is aluminium trichloride, and this reaction proceeds, and this chlorine will react if this aluminium, and it will convert into aluminium tetrachloride, and this acyl group will attach to the benzene ring, and the final product is acyl group added to the aromatic compound by Friedel-craft acylation. This is the final product, and this is the byproduct. So this reaction has a mechanism we will discuss in the next slide. The step one is the formation of an electrophile. If so, the formation of electrophile isopropyl chloride that has a chlorine group, and this chlorine group will break its bonds and attach to the aluminium trichloride and form a carbocation and aluminium tetrachloride. In the second step, this electrophile will attach to the pi bond, and this pi bond will breaks, and it will attach to the carbon that is present in the benzene ring, and this is the uranium ion. In the third step, this proton will release and attached to the uh, attached to the chlorine that is present in the aluminium tetrachloride, that is unstable and act as a nucleophile. So in this reaction we will have our final product, that is as isopropyl benzene, and we have the final product isopropyl benzene, and a byproduct that is hydrochloric acid, and the catalyst that regain its original position. So this is all about the Friedel-craft acylation and alkylation. Thank you so much. Allah Hafiz.